and your K18 CS012. So this is the fifth experiment in data structures and algorithms lab, and this is a double A linked list. So I am declaring the functions in initially, that void first, void display, void middle, and void delete. So now I'm creating a structure called node, and in that I'm initializing into data structure node into previous. Pointing, this is a pointer to the node, and struct node star next, that means this is the next pointer, next points to the next. So I'm declaring a struct node star head equal to null, that means this is a pointer, head is a pointer pointing towards null. And now this is a void first, so I'm collecting the data here. Though this struct star node new node equal to struct node star m alloc size of struct node, that means this line is used to create a memory space if there is no data. And now new node tends to data, that equal to data 1, and new node points to the previous, that equal to null. If we insert the first element, it will, next there is no element, so it will point to the null. Now new node equal to next, that equal to head, and if head is not equal to null, head tends to previous, that equal to new node, head is equal to previous. This line execute if there is a first element. If there is no element in a queue, in a linked list, this will execute. So if there is an element, that means head is not equal to null, that means there is some other element. So we are, so this, if there is an any element in previous, so this will execute. If head is not equal to null, head tends to previous new node, and head equal to new node, that means from here it will come again and it will store this. And now we are going to the void display, and we are checking if head is equal to a null pointer. So we are checking the whether the it is a last element or not. So if it is non element, there are no elements to display. And we are giving a statement that struct node in creating a temp variable for the node, temp equal to head, and we are giving a while loop by giving the condition that temp is not equal to null. So if this satisfies, so the data will printed by using the temp variable, and the data is printed and temp is pointing towards the next data. Uh, and now is a void middle, so we are asking data and location. We are getting that, and we are declaring this line that struct node star new node equal to struct node. This is node star means it is a pointer, that means m alloc size of struct node, so it points this memory location. So a new memory is created for this, and new node tends to data, that equal to data 1. So we are giving the if condition that head equal to null, so we cannot add anything. So if if head is not equal to null, this will execute struct node into, struct node star, this is a common for everything. And we are declaring a temp variable equal to head. And now in for loop we'll declaring int I equal to 0, I is less than location minus 1, and incrementing the I. So in this we are assembling temp equal to temp points toward the next. If temp is equal to null, the position is not possible, that means it will check the position whether it is last position. The position is the last one, it will not possible to add. And now we are creating if this will not continue, again it will come here new node next tends to the next, that equal to temp tends to the next, and temp tends to the next, that equal to new node. Now new node points to the previous, that equal to temp. So we can see, so we can say that this line helps to while creating allowing that it will check the position if there are three numbers, example 1 2 3. So where, so the positions counts 0 1 2. If we enter the data, 2 should be inserted in the first position, so it will check whether so there are three elements in the position 1 where we want to insert 2. So 0, after 0 there is a position 1, it will insert 2, and the position 2 is changed to 3, and 3 is changed to 4. So for changing that, we are using these statements, and this is void and we are collecting the int data one. We are checking the condition that if head is equal to none, so we cannot that means we cannot add anything to end. So if head is not equal to null, so the programs remaining will execute that. It will create a new memory space and new node tends to data that equal to data one. That means this line of code is used to add the data at the end. So it will keep on checking whether the temp next pointer is equal to null. For example, if you give the three values 1 2 3, after the 3 the next variable will point to null. That means head is equal to null, so it will check up to the last condition. Whenever it will point that the last position equal to null, it will create a memory allocation. It will point to that towards that memory allocation and point that to the null. So in this way this void function will work. And now the last one is void delete, and not last one, delete. This is one void delete end. That means the value which is at the end, it will be deleted. For that we are pointing towards the head. We are checking whether it is a last element or not, whether there is any elements or there. If there are no elements, it will print element, no element to be deleted. If there are any elements, so we are checking by using these conditions. So from 1 to we are checking whether this is a last element, whether this is a last element, whether this is a last element, so that if it is a last element, it will be deleted. So these codes are used to check whether to find the last element and delete. So this void delete, when this function is used to delete the element which is in the front. So we are checking whether head is equal to null. So the head points toward the null. There is no element to delete. That means there are no elements in the array or queue. So now here there is a on this line of code used to check whether the first element. That means there are three elements. The first one, so struct node point equal to head, we are creating a point and assigning to head. So head equal to head points to the next point, uh, points to next, and it will equal to null ptr. So we are freeing the point. That means we are checking whether the first this line of code helps us to check the first element in a queue or array, and it will delete. The free point is to delete the first one. This is a pointer and assigning to head. In this way this one will come. And here void delete, you are asking uh, user to enter the data which you want to delete. If there are 2 3 4 5, I want to delete 5. If the 5 is entered, first we'll check whether the 5 is there in a given element. If there, we'll delete it and we'll display the remaining. For that, first we are checking whether there are elements. If there are no elements, it will print no elements to delete, or else it will check the given value. So the input is taken. So these all, wait, yeah, up to here these codes are used to check whether there is an element or not. Yeah. So delete by element means first we are storing that element. We are creating a new variable, taking it as pointer, and we are keep on checking whether the given value is present in a given data. So if there is the value given by the user in present in the given data, so it will delete and remaining positions are adjusted and display it. If they are not there, it will print not possible. So, and here it is a main function. We are asking to insert at beginning and middle, delete the data, delete at end, delete at front, delete, display the data, and exit. So these are the switch cases based upon the input of the user. These switch cases will come again. So this while loop is continue until the user want to exit the program. So now let's say how it works. Yeah, and first I want, there is no elements, so first I am giving 2. So it will create allocate space and uh, store the memory location, store the 2, and here after 2 there is no value. That means next points towards the null. So now I'm inserting at end. So 3 is at end. I'm displaying. So there are 2 and 3. So now I want to insert at the middle. So there are two elements, 0 and 1. So I want to insert 1 1 1, and the position is uh, first position. I'm entering the first position. See, now I'll show you. So 2 and 3 is there. In between 2 and this there are many positions. So initially there is no position, we are entering 1 1 1. Now I want to insert at middle, again L press. So now there are 0 position, first position and second position. I want to enter the second position. See whether check 0 0 0. I want to enter at the second position. I'll print out. So first position, 0th position is 2, first position is 1 1 1, second position is 0, third position is 3. So in this way this will work. And now delete the data. I want to delete 2. Yes, 2 is deleted. Again I'll press delete the data 7. See, not possible. That means it will first when I enter the 7, it will check whether the 7 is given in loop. If there is not there 7, it will print not possible. Now I'm pressing delete at the front. First value is deleted display. So 0 and 3 are there. Now I'm deleting at the end display. Only 0 is there. So now and delete the data, which is again so if you press now only one element. If you press front, 0 is deleted. If you press last, 0 is also deleted. And let's see, delete the front 5. So no element to be displayed. So to exit. In this way this program will continue work doubly linked list. Thank you.